Hi students, the third problem is assuming that the frequency nu of a vibrating string may depend upon applied force F, length of the string L, mass per unit length M. We have to prove that the frequency nu is proportional to 1 by L into square root of F by M using dimensional analysis. This is a very important numerical problem which may be asked in the board examination also. First of all, what is the meaning of frequency of a vibrating string? A string is vibrating just like the vibrations of a veena or a violin or guitar string. It is vibrating. The number of vibrations per unit time only is called its frequency. Therefore, the dimensions of frequency nu must be equal to the reciprocal of its time period. Is it not? So, it is the reciprocal of the time period means then its dimension is what? T power minus 1. So, this is T power minus 1. Now, the dimension of force is mass into acceleration. So, its dimensional formula is mass m into acceleration is what? M L power minus 2. L T power minus 2. M L T power minus 2. Dimension of length. Length is capital L. This is the dimension of m. What is m here is mass per unit length. It is called a linear density. Okay, mass by volume is actual density we have studied. This is mass by length. Mass by length is called mass per unit length or linear density. So, this must be mass by length. So, this is m L power minus 1. So, these are the dimensional formula for the four physical quantities we are going to relate in this expression. Okay, children. So, frequency is represented with a Greek symbol nu. Nu, nu. And L is length, F is force, M is mass per unit length. So, as per the given expression, the frequency depends upon three factors. That is, the length L, force F, and mass per unit length M. But how many times we don't know. We have to assume. Therefore, I am going to write the frequency nu is proportional to L raised to the power A into F raised to the power B into M raised to the power C. Normally, we write this is equal to some constant k into and all, but it is not necessary because we have to prove that it is proportional to. Is it not actual equation? We are not going to derive. Just this proportion only we have to prove. Therefore, on both sides, now I am going to equate. Now I can equate the dimensional formula of the left hand side and the right hand side. So, I am going to substitute. So, if we substitute the dimensions on the left hand side, what is the dimensions on the left hand side is T power minus 1. So, T raised to the power minus 1 is proportional to, or we can write equal to also because it is only dimensions we are substituting, is it not? So, the dimensions on the right hand side, L is length. So, what is this dimension is capital L. So, this is L raised to the power A into force M L T power minus 1. So, this is M L T power minus 2 whole power B into M. So, this is M L power minus 1. So, M L power minus 1 whole to the power of C. So, now if you substitute the dimensionless constant, since it is having no dimension, we need not substitute also. Okay, because constants do not have dimension, so we can substitute this proportional by equal to symbol also. Okay, now you look at the left hand side, here this is the time. There is no mass factor and length factor, is it not? But I can write them in the powers of 0 also. So, now on the left hand side I can write m raised to the power 0, L raised to the power 0, t raised to the power minus 1. So t raised to the power minus 1. This is on the left hand side. So this is proportional to, now all the three factors in the same order, m, l, t, the same order I am going to write. Look at the first bracket here, there is no mass term, and here there is a mass term, m. Okay, m raised to the power b is here, and here m raised to the power c is there, is it not? Therefore, totally m is raised to the power b plus c. So first term is m raised to the power b plus c into, now length, first factor l is raised to the power a here, and here also l term is there, l raised to the power b, and here l raised to the power minus c. Therefore, totally the length is having the powers a plus b minus c. Here a, here l power b, here l power minus c. The third term is time. So here there is no time factor. Here t raised to the power minus 2 whole power b. So t power minus 2b. And here there is no time factor. So I will write into t raised to the power minus 2b. Okay, children. Now here what is on the left hand side? Mass is raised to the power 0. So m power 0. Okay. And right hand side mass is raised to the power b plus c. So equating the powers. So the next step is equating the powers of m, l and t. So left side m power 0 means right side m power b plus c. Therefore b plus c must be equal to 0 or c must be equal to minus of b. Whatever value you get for c, no, if you take the negative of that, that will be the value of b. Next, L term, left hand side L term is 0, power is 0. Here L is a plus b minus c. So I will write as it is. So a plus b minus c is equal to 0. Let it be as it is. Coming to the time factor, you see, here left hand side time is raised to the power minus 1. The right side time is raised to the power minus 2b. So equating the powers, I can write minus 2b is equal to minus 1. Minus 2b is equal to minus 1. So 2b is equal to 1. So b is equal to 1 by 2. B is equal to 1 by 2. Understand? Now you look at the first factor. C is equal to negative of b. Is it not? What is b equal to here? Plus half. Therefore, C must be equal to what? Minus 1 by 2. Minus of 1 by 2. So B is equal to plus 1 by 2. C equal to what? Minus 1 by 2. So the value of B and C are known. That I am going to substitute in the middle term. A plus B minus C equal to 0. So in place of A, we have to find the value of A. So A plus, what is the value of B, children? 1 by 2. So I am going to substitute 1 by 2 minus of, what is C actually? C is minus half. So minus of minus half, okay, minus of minus half. So this is equal to 0. So A plus 1 by 2 plus 1 by 2 is equal to 0. Half plus half is 1. So when this 1 you take to the other side, A will become minus 1. Okay, therefore A is equal to minus 1. Understand? So you look at this expression, nu, frequency nu is proportional to L power A. So therefore nu is proportional to length to the power A. So in place of A, what shall we substitute? Minus 1. Okay, L power minus 1. Okay. Force F to the power B. So F is raised to the power B, that is power 1 by 2 into mass per unit length m is to the power c. So c is power what? Minus 1 by 2. Or nu is proportional to L power minus 1 means what? 1 by L. Is it not? L power minus 1 is 1 by L into this is F power half, this is M power minus half. So I can write F divided by M whole power half. Is it not? Or I can also write R, okay, or frequency nu is proportional to 1 by L into square root of F by M. So this is the final expression. Understand? So what is asked here to prove that nu is proportional to 1 by L into square root of F by M, is it not? Here we have proved nu is proportional to 1 by L into F by M. So this is the way, step by step. First we started with writing the dimensions of all the quantities on the left hand side and the right hand side. That is the best method of learning. Okay. After that, substituting on both sides. Then equating the powers of m, l and t and getting the solution for the values of a, b and c. Then substituting in the main expression, you will get the required result. I hope you must have understood well. Fine.